Good morning, folks. Thanks for joining us here at the Onyx Community Meetup 2024. This is exactly 1 year since the last meetup. It happened on the same day last year. We're really happy to have you here. Looking forward to a great session. We're starting off with a keynote from our VP, Imad here. Imad, take it over. Thank you.
Okay. Hi, everyone. My name is Imad Barsoum. I am CVP of AI Model and Application Team at AMD. Welcome to AMD. Good to see a lot of familiar faces and old colleagues, and a lot to see all the progress Onyx has been doing year after year. It's honor for me to be here with all of you and looking forward to meet you in person. One thing it will be good to see, so Onyx started in 2017. Almost 7 years ago. It's great to see what was the landscape and the reason even that Onyx was created 7 years ago and what is the current landscape and help us to see what the future or the trend going forward. Onyx started to solve a specific problem. Pretty much we have a lot of deep learning framework. Most of the focus was on training, not deployment. And it's very difficult to optimize all those framework across the various devices and scenario. So Onyx was created to create a standardized IR across all those frameworks so every company can optimize single IR and single on their devices. And the community itself work together to create an ecosystem and workflow around Onyx to convert and extract model from all those framework. So it was created by the industry to solve problems that face all of us. Also, during 2017, there was a lot of breakthrough, especially on the modeling and AI side. AlphaGo came in 2017. It was the first AI model to beat a professional Go player, which people did not expect it will happen that soon. Most of the model was based on CNN and RNN. There was a lot of innovation in those areas. Also, GAN had a lot of attention and a lot of work how to improve GAN and stabilize GAN training. Attention itself, there was, due to its promising, there was a lot of work on attention mechanism across all model architecture. There is very famous series of paper back then in 2017 and before, image to text, it was convolution-based model, which they show, approaching most of you remember those paper, they show you generate a text describing what it's in the image, and when you select each word, it highlights the patch in the image corresponding to this word. For example, when you say bird flying over the sea and you select bird, you will see the patch highlights the bird on the image, which actually was pretty great back then. Also, another breakthrough in 2017 that people didn't fully understand the ramification, the transformer paper. It was created, published the same year as Onyx. Attention is all you need, which show how combination with self-attention, cross-attention, and feed-forward layer and some normalization is pretty much all you need to create encoder-decoder and show impressive result in machine translation. Model size, most model size back then were around 100 or 300 million. Those were considered big, mostly were below 1 billion. There was a couple more than 1 billion, but mainly to show off infrastructure and test and not usable model. So this was roughly the landscape around 2017. So what is the landscape today? We have also still a lot of framework. Some framework died out. Other framework, their utilization pretty much is pretty low. But PyTorch in 2017, PyTorch was created in 2016. So in 2017, it was only 1 year old. PyTorch now is one of the most used framework. TensorFlow is also very popular. JAX is rising star and more model also coming on JAX. So those frameworks still take most of the percentage of deep learning framework in the industry. Okay, why Transformer? Transformer, of course, as all of you know, is taking over everything. The question is why. One of the breakthrough in the transformer, it show you can is the pre-training. You show you can pre-train on unsupervised on a large amount of data. Pretty much you remove the human label, you remove the bottleneck. So now the scalability is just more compute. Everything is automated. Data is unlimited. You have all the internet, all data from sensor. You don't need expensive labeling process, which was limiting how we can scale. And it show as you scale, transformers scale very well and understand the structure of the data, and you can do even zero shot and get a good result. And that's what improves the transformer, and that was why transformer was very important and why everyone moved to it. There is a well-known paper about scaling law that show you the combination of compute, data size, model parameter. And based on those, you can estimate, if you want to get this accuracy, how much data, how much parameter. And this scaling law is actually almost accurate, and you can predict, if you want to train to get this accuracy, this is the size of the model, this is the size of the data. This is why everyone now trying to get bigger and bigger infrastructure. Most transformer converge to the same accuracy as long as you have enough data. Also, there are a lot of work on non-transformer model. The two famous paradigm is SSM, state space model, which is Mamba and Mamba 2 came. Recurrent like Griffin and Phoenix from Google DeepMind. What's the difference between those and our old friend LSTM and GRU? That those model now can be trained in parallel, not sequential, so have the same advantage as transformer. And when you run in inference, you run them sequential. However, they don't have quadratic attention like transformers, so they are cheaper in compute. They don't have KV cache, so increase the length does not increase the buffer. So people are excited. Currently, they are competitive to transformer up to 14 billion. They don't yet, or we didn't see yet how far they can scale, but there is a lot of work and advance in this area, including in improving transformer compute by approximate the attention, by reducing the quadratic. Other areas advances and special came is on SLM, small language model. Serving LLM is costly. So people now try to think how's the best I can get from small LLM, or it's called now SLM, is that, and the combinations that help, which famous model from Microsoft like Orca and Phi, is clean data and way more synthetic data generated from a larger model. Pretty much it's form of distillation. And those models actually beat older, very large models that were 1 year old. Some of them even are in the close vicinity of GPT-3. Even GPT-3 is 175 billion parameter model. And if you tune it further on your task, they are actually pretty good, and you can run it on the premises, on the client. You don't need cloud for that. So there is a lot of progress in this area. Other progress for LLM came is integration with the enterprise. Like RAG, instead of getting the result from the model parameter, you can actually ingest and index data of the enterprise of the customer and feed this data to the LLM to get the final result. So pretty much is search on steroid. And there is a lot of progress and a lot of algorithm, advanced RAG 2.0 and other that try to improve RAG. LAM also is becoming important, a large action model. Instead of you ask question, it's use agent to be able to monitor and give you the context at the right time. And this has become more and more important, and use LLM for that. Also, if you think about it, and this I think Karpasi also said that, LLM is becoming more like a kernel of OS, like its own operating system. So there are, for example, work in like Toolformer from Meta and similar work on other, in which while you search or provide prompt for LLM, it can launch application for you. If you ask for mathematical equation, it will launch calculator and apply it there. If it can search the web, it can go to Wikipedia and get information from there. So it's becoming more and more integrated, give you all the answer and not all of them, and learn how to use the tools that all of us use it, including parse data in your computer or in the cloud. So there are a lot of interesting applications are getting enabled in LLM. Of course, most new generative model now are multimodal. So now we are not talking about text. We have, the focus is one universal model to rule them all. So we are talking about image, video, audio, and dealing with this data have its own complexity. And to scale even further and have the model perform well and better accuracy, of course, mixture of expert becoming very, very important, and depend which scale you want to go for. Mixture of expert, you can go from small scale to pretty large scale. Something that came around the time of GPT-3 that surprised us, and it took a while to understand what's going on, is in-context learning. So In the past, you do pre-training, then you fine-tuning. In context learning, you don't need the fine-tuning. You simply write the example question and answer or the pattern and answer in the prompt, and then you ask the question, it will answer unseen questions. So this is becoming something very, people get a lot of exciting about it. There was a lot of research on it to see the limit and how to improve it, but be able to on the fly, the model learn a new task without fine tuning, that become very interesting. Also something that all of you familiar now, and is prompt engineering. And I see now job opening about prompt engineering with something, it's kind of interesting. On the model side, we already passed the 1 trillion. We already passed the 1 trillion parameter model, and I expect soon we'll pass the 10 trillion parameter model. On the data set side, we now train 15 trillion token and more, and with multi-model we train more. So if you look at the landscape, it's totally different than what it was in 2017. Everything is bigger and bigger, and we don't see slowdown in terms of model size increase. Okay. So AI at AMD, AI is important for all of us and for every company. At AMD, we have hardware from data center like the Instinct and the Epic CPU to the client, all the way to embedding. So all the way to embedding an IoT, and every of those hardware have its own trade-off, limitation, constraint. Some of them are very different architecture that people used to, a mix of FPGA and other, and some of them power is more important, performance is more important, some of them size is more important, and the one thing that glues them together is Onyx. Okay. Onyx at AMD is very important. We use it all over our product. We also, of course, use Onyx runtime and the tool. Even Onyx format itself, having a format independent of the framework, is very important. But also there are some, besides the format, having a unified workflow across all your devices, that also very important, and make life for everyone easy. So especially quantization, extracting the model, visualization, and all the tools that you expect to analyze any model, standardize that on a single format is very important. AIPC, in AIPC, Onyx is the dominant format that is being used. Also, one big benefit of Onyx is you, the community. All of us working together and share all the challenges that we are facing in AI and try to come up with a general solution to solve those problems. That's what make Onyx great and make Onyx improving, and its popularity keep increasing year over year. Okay, so what will happen in the next 7 years? And it will be good also try to predict where we are now, what the trend. Onyx is very important and need to keep evolving. Generative AI, it was a pivot point in the industry, and that accelerates the rate of improvement of AI. A lot of problem in the past, you couldn't solve it with ML. And you need a lot of heuristic, and you need human in the loop. Some of those problems now, actually can solve it. A lot of problems that you couldn't solve it in the past, you could solve it now with generative AI model, and this is what very exciting to a lot of people. However, we need, as generative AI is continue to grow at faster rate, we need also to evolve Onyx at faster rate. We need to keep up with the framework and also support all the framework capability. Model architecture, both transformer and non-transformer. Innovation, for example, ML-based optimization now is a standard used across the industry, like speculative decoding, looking forward, like Eagle and other. How you represent those in Onyx? Are that multiple graph, or single graph, or those? Also, for example, mixture of depths, which is dynamically can skip layers. So there are a lot of innovation to reduce the compute of the model, because this is a big problem, especially on the client and a lower end device. And update and innovation coming are on daily basis. So to be able to represent that on Onyx is very important. Another thing is low precision, especially for the NPU. There are a lot of innovative new type that's like OCP type, like the MX FP8, MX NT8, and all those type, and be able to present those type in Onyx, including advanced quantization technique will become crucial. If you look at it, LLM is memory bound. And everyone try to solve that beside algorithmic is to go lower and lower precision. And there are a lot of advanced techniques that now take into consideration the actual architecture of the model to get the accuracy up. And those are evolving and keeping pretty much each month. I see a couple of papers with new algorithms claiming they are better than the old one. And there was 2 recent papers about the era of 1-bit and matmal free on it. So those techniques, we need to think about how to be able to generalize, be able to support those techniques being plugged in Onyx workflow and also support it as type on Onyx. So looking forward for today's agenda and for all, hopefully we'll be meet in person and all the work, and looking forward to see, and it's great to see all of you. Thank you for coming and welcome to AMD.